Hello, everyone. Hi, welcome to this new live session, Code and Deploy. Today we'll have a great topic and also a great guest. We'll be working with AI agents, so probably may hear about that. So it's a very interesting topic, and there are a lot of traction on that. So it's very great to start coding on that. As we are waiting for people to join, I would like to mention that if you are interested or if you are developing something around GenAI, there is a project that is called OPA. I will put the link in the chat. And that project aims to help you if you would like to deploy and the deployment of any GenAI application. Can be a RAG or visual Q&A or something like that. If you have any questions, please reach me out. I put a link in the chat. We are here to help you and also to support you if you have any doubts. So it's let us know if you'd like to know more. So let's jump. So put us in the comments where are you watching us. So as we are waiting for more people to join, we can start talking about the topic, right? The AI agents. What is an AI agent? Why is it important? And of course, I will not be explaining in detail because for that we have our great guest. But we know that these things are challenging. And why it's important to have this session is that these things are challenging to deploy because the first thing that you need, for instance, is a framework, right? So to have a framework is a mess. It's very complicated to make it real what you are developing or coding. And one of the greatest framework to that is Haystack. And this is why we have our guest from today, right? So we have a very special guest, and his name is Bilge Yücel. She's a DevRel from deepset, and she's actually working with Haystack, and she's coding and doing very interesting things on that. So, hi Bilge, how are you? Bilge.
Hi, Eze, how are you? And thank you for having me. I'm super excited for this event.
Thanks to you for joining us, especially given the time difference. I know that you are not in US, so you are a bit away of US. So I know it's a bit late for you. And tell us where are you based?
Yeah, I'm based in Istanbul, Turkey.
Oh,
You
nice.
can say that I'm based in Europe almost.
Okay.
And it's 7 p.m. here, but there's still sun out there, so it's not too late, at least during summer.
Okay. No. But we really appreciate you having here. We have some people writing from Amsterdam, so it's pretty close. So I would love to be there, to be honest. But yes,
Yeah, I
okay.
have a colleague from Amsterdam.
Oh, nice. So tell me something about you. I mean, how you started to work with AI. Every time I work with a peer, like with a DevRel, evangelism, or these kind of roles, I always wonder how they started in AI. I mean, how was your journey in AI?
Yeah, actually, I was a web engineer, so I was building front ends for applications. I was using React and JavaScript, but I was always curious about AI. Like I was using Grammarly and Google Translate back then, and I was a bit uh, impressed by them, and I really wanted to learn about the science behind it.
Yeah.
So this has been my introduction to AI. So I was a bit curious person and I wanted to learn more. And when I learned more about AI, I also wanted to build something with AI. And that's why I'm also doing this Darrell, because I really love teaching people. I really love showing how to build something with AI. So this is also what I'm going to do today with everybody else in this call. Um, so yeah, I can say that Grammarly and Google Translate are the reasons why I'm here today.
Yeah, we always start with that, right? When if we are not native speakers, that's the first tool that we use, and we are impressed. Like, hey, that can help us to sound a bit native, right? So that's great. That's great. And tell us what you do at Haystack, DeepSect. Sorry.
Yeah. So the Haystack is an open source LLM framework for custom LLM applications. It's built by and maintained by deepset, but it's an open source project, so you are also welcome to contribute, open an issue, and of course use it freely. And the idea behind Haystack is the GenAI world can be complex. If you are using Python, sometimes you don't have the knowledge about the knowledge about AI. So what Haystack is trying to do is to decrease this level of knowledge and make sure that you can also build your AI application, even though you don't know everything about AI. So that's the idea behind it. And I'll show you the details. And what I do at deepset is I write tutorials, I build demos, I help documentation, I go and teach people how to build with Haystack, I go on talks. So anything that you think that is useful for you to learn Haystack, it's usually coming from our team, from me and from my colleagues.
Amazing, amazing. That sounds great. That sounds great. Yeah, let's talk about what you'll be doing and why you think that that's important to developers, and basically a quick introduction on what we'll be doing for the next 15 minutes, 45 minutes.
Yeah, so the what I'm going to show today is first, probably there are some people who are familiar with Haystack already, but some people might not be. So I will start from the beginning, show you how to build anything with Haystack very briefly. And it's a very simple framework, so you'll definitely understand a lot about it if you have a little bit of Python knowledge. And then I'll build something quite complex. We are going to build our agent that we're going to introduce tools. And our agent will decide which tool to use based on the user query, call that tool, get that answer, and return that back to the user. So I will show you every step of that agent. And if you need to customize it further, I will show you the ways to how to customize it further also. So you don't have to stick what I will be showing today. You can also, after this session, try to build your own agent with your customizations.
Amazing, amazing. Okay, let's do it. For the audience, any question you may have, and that's the idea of this session, is to be interactive, live session. So if you have any questions, we may have at the end a Q&A session. But if you have any questions or something that you would like to know during the session, don't hesitate to put your comment, because our idea is to make it interactive. So let's start it.
All right. Yes. All right. Thank you. Thank you for this introduction. So, as I said, Haystack is an open source framework for building production-ready LLM applications. So with Haystack, you can do semantic search, retrieval augmented generation, or conversational systems, or anything that you can imagine that you can build with LLMs or language models out there. We have support for almost everything, I can say. If you think about the architecture of Haystack, there are two main building blocks in Haystack that will be required for you to know. One of them is components and the other one is pipelines. Components are smaller things in Haystack. They can be embedders, retrievers, generators, converters, routers. So the idea is they can do one thing, and by connecting these components to each other, you are creating your pipelines. But the pipeline structure in Haystack is directed graph. So you can have loops and branches in your pipeline by connecting components. So here is the image of a pipeline. This might be one component. This is another one. And as you can see, this branches out. There are two components. Then you can merge and get one solution to this input. So that's the main idea. Without further ado, maybe let's start building already. So first example that I want to show you is to how to build a web QA system. So here is the image of the application or the pipeline that I'm going to show. The square ones or the rectangle ones in green are components. So we're going to use link content fetcher, HTML to document, prompt builder, and generator. And we're going to connect all of them together. But before all of that, let's maybe import Haystack. And we're going to also need this package because we are using HTML to document component here. All right, waiting.
So you'll be using like the Haystack APIs, right? I mean, the methods that APIs Haystack can provide you just to make it easier, right?
Yeah, exactly. So I will be using the Haystack components to have a web QA system. Maybe I can mention a bit about this web QA system. The idea behind this is we are going to provide a URL to our system, and then we are going to provide a query. It can be anything that you want to ask to this web page that you have out there on web. And this pipeline will get the URL content through a link content fetcher. This component will convert the content into Haystack documents, which is the data type that we are usually using in Haystack pipelines. Then we're going to feed the documents coming from the HTML to document component and our query, and we are going to build a prompt to instruct our LLM to generate an answer based on the web page content. And our generator is basically the connector to an LLM. So we are going to generate an answer using the generator.
So
This is
like
what I'm going to build.
that's like the step before RAG, right? Because you are not doing indexing, you are just picking the text that you have and you are putting that on the LLM so they can give you an answer based on the document, right? Or did I get it
Exactly.
right? Okay.
It's like, so RAG is made up from two steps. One of them is retrieval and the other one is generation. And retrieval step, this is exactly what I'm kind of skipping with this link content fetcher and HTML to document. Instead of retrieving relevant documents, I already provide some documents to my systems. Okay. So I kind of skip the retrieval part of RAG and I do the generation. But the idea is kind of the same. If you replace this one with retrieval, which I will be also showing you later with the agent example, you will be reaching a RAG system.
Nice. Great.
All right. So we are here. So I will be using an LLM from Hugging Face. To be more precise, I will be using the inference API from Hugging Face. That's why I will need an Hugging Face token. I will go and get it. Here we are. All right. So to show you how to exactly these components behave, maybe we can, instead of like forming a pipeline, we can try to run them one by one. So first I'm going to import my first component. I will be only doing that once. I know that's not usually fun, but the thing is, if you start typing from haystack.components, you will see a list of component types, let's say. And the first component that I will be using is the link content fetcher. So I'm going to go there and import link content fetcher. There we are. All right. Let's say that it's a fetcher and initialize it. Maybe, yeah. All right, so if you also go above the components, all right, you'll see the doc strings here. So you'll see the parameters that you can feed in initialization. So that's something that might speed up the process. So I will just run it. And if you also, every component in Haystack has a run function. That's a requirement. So when you have a component, you can initialize it, and when you call the run method, you will get something. And so for this component, I need to provide a list of URLs. So I will provide that list, but just that because I know it, I'll just go ahead and as a URL give the get started page of Haystack. So here we are. Here's the URL. So let's run this and see what the output is. So as you see, this is like the content of the web page. We see like some HTML tags.
The HTML, yeah.
Probably there are some JavaScript code, some very, like the content is kind of missing somewhere here, but we have so much irrelevant information here. So that's why we are also introducing the other component. Maybe I can, this one, and I'm going to introduce you the HTML to document component. this component will take this gibberish text and get the relevant information from that web page. Yeah, maybe let me go faster here. I will get here, converters, import HTML to document. I hope yes. Yeah. Okay, then we're gonna say that it's a converter, HTML to document. All right. Okay, so the thing is, first we need to get and assign this to a variable. Let's go. And we're going to take this one. We're going to run converter.run. And here, HTML to documents expects, let's see, oh, all right, expects sources. So this is what I'm going to provide directly by getting it from the fetcher. So let me run this cell again. And sources, we're going to add web content, but we're going to use the streams field of it. So let's run this. All right. So first we had the, if I can print the web content again. So this is what we retrieved from, what we crawled from the website. Mm-hmm. But by feeding that information to the HTML to document, we now have a Haystack document object, which only has the text content, let's say, of the web page, which would make sense to ask questions.
Which is just one document. Or it's,
yeah, which it's just one document. Okay. Exactly. Okay. It is just one document. So this is not a very big page, so I can directly put that into my prompt. So this is what I will be doing. But for that, I need to create my prompt builder. So I'm doing that again. Components, builders, import, prompt builder. All right. So this prompt builder gets the template gets the prompt template and renders the prompt. I'm saying rendering because this prompt builder can accept variables. And that's why we can also use Jinja syntax in our prompt. And this is what I'm going to show. So when I'm defining my prompt, which thinking that it's going to be like a RAG prompt, I will say that answer the question based on the giving documents. Then ideally, I am going to provide this component a list of Haystack documents. And since I can use a Jinja template, I can iterate over all documents and get only their content, because as you see here, each document have also different data like meta or the URL in it. So if I want to use the content of it, I need to show that. So I will iterate on docs, and I say that only use the content field of it. And let me end the loop here. So this is where I will be providing my documents. Maybe I can also say that these are my documents. And at the end of the prompt, I will say that this is my question. And here I will be saying that question. So as you see, I have some Jinja syntax here, but these information will be filled by outputs coming from other components using prompt builder. All right, so this is the prompt that I will be using. And let me maybe initialize my prompt builder with that prompt. What I need to do is just give it to the prompt builder. But let me make, yeah, this should work. And so if we go back here, we have the link content fetcher, HTML to document, prompt builder, and a generator. Mm-hmm. So the next step is creating the generator. So haystack dot components. Yep, generators. Okay. forgot the from here. Import. I will be using Hugging Face API generator here. So we can say LLM. I will get this one. So this component has different initialization parameters here. So first I need to define the API type because this component can connect to Hugging Face's other APIs as well instead of like the inference API that we're going to use it. And I will also provide API params, which I will be passing the model that I will be using. So maybe let's start with the first one. So I will do API type. And for that one, let me go back and check the exact name of it. It's going to be serverless inference, serverless inference API. And the API params, which we'll be providing our model, is going to be, this time I will be using Mistral's model. So I will be using this one. That's why, oh no.
So you will be using the
API.
You'll be using like the API, not downloading locally on your computer.
Yeah, exactly. But you can also download it. Since I'm doing this on Collab, I'm trying to use the API, but this is not for production. Maybe I can give that thing. Since this is a free API, don't use it on production.
No.
Try to use it on your server or use their other endpoint for that.
That can be challenging conversation locally, externally. I mean, how to optimize and everything. But that's not part of this. Yes.
Yeah.
Yeah.
So all right. So here I just gave the exact key that I took from Hugging Face. So let me run this again. Oh, and also forgot to run this. So let's run that one. This. All right. All right. Yeah, this is components. Nope. All right. Yes. Yeah. And then, let's maybe try to run this LLM alone and see if it works or not. So what should we query here? I can maybe ask like something basic that the LLM can answer from its knowledge just to check the connection. So what is the capital of Germany? I love asking this question. It takes some time. All right. Yeah, in the reply, we get this huge text
as usual
from the LLM. Yeah, because we haven't limited its like max token or anything. And we also get the token size here. 360 tokens were generated for the sensor. All right, so we have every component that we need for our pipeline. So let's go ahead and create our pipeline. I should not forget saying import. All right. So I am going to initialize the pipeline here, and I'm going to add these components one by one to my pipeline, and the order doesn't really matter, but I'm going to give a name for each of them, and you will see the reason why after I did that. So pipeline.add components. So let me maybe scroll a bit. All right. So for this add component here, we are going to give a name for each component, and we are going to provide the instance of the component. So maybe let's go in the order and say that it's a fetcher component and the instance is fetcher. So I'm going to copy and paste it again. The next component is converter, this HTML to document component that we have. The third one is the prompt builder.
And the name
of course,
you put,
the name and
you can use whatever you want. Yeah.
Exactly. You can use whatever. It's just easier for me to keep it same
Yeah.
so that it doesn't create any confusion. But sometimes you have like two generators in one pipeline. When that's the case, you need to give a better name instead of giving just LLM. All right, let's copy this line again and paste it, and let's give the LLM or generator. So if we run this pipeline now, and we have a great method for pipelines, because sometimes pipelines can get quite big and it becomes quite hard to imagine by looking at the code. That's why we have this method, helper method. If you say like pipeline show, it also works on collapse. So like it gives you the image of the pipeline,
Oh,
but you will
that's
see
great.
that it's not as we want it to be, because there are components, but they have one input, one output, but they are not connected to each other because we haven't created the connections yet. So let's
Oh,
keep this image here, because now I'm going to create the connection. So I'm going to call the same pipeline again, but this time use the connect function. And this time we are going to connect them. So I'm going to connect the fetcher to the converter, converter to the prompt builder to the LLM. As I said, I can freely do anything as a pipeline. I can even connect converter to the prompt builder and the LLM at the same time, if it makes sense.
I was going to ask you that because I thought that once you are creating the components, I say how they are connected. Probably because of the order, I don't know. But that makes completely sense that you need to connect them, of course, yeah.
Yeah, when you look at the code, it's more verbose, because first you need to add component one by one, then you need to connect them. But if you want to do something quite custom, you need to be quite flexible. And this architecture provides you that.
Nice.
So let's start connecting components. And to connect components to each other, I will be using the names that I've given here. So the fetcher component, I will connect it to my converter. But as you see, the way the components are connected are with the names of the edges of components. So this is what I mean. So fetcher has the streams output edge, but the converter has the sources input edge. So for me to easily connect these two components, I will be very clear about which edges to connect. So I will say like fetcher dot streams will be connected to converter dot sources. If the names match, then I don't need to specifically say that. But if they have a different name, it makes sense, and I am kind of forced to do that. Otherwise, this pipeline will raise an error. Then for the converter, I will use the converter only has one output, so that might be okay. But how I'm going to connect these documents to a prompt builder is actually hidden in my prompt, because in my prompt, I am accepting docs and question variables. So that's why the converter will go to prompt builder dot docs. This docs variable was also something that I've given in my prompt, so this could be anything. Then I'm creating another connection here, which will be the last one. I will put the prompt builder here. Since it has the prompt output and the prompt input, I can directly connect prompt builder to my LLM. So let me run this pipeline. Yeah, if you see the emojis and this text, it means that you have successfully connected your components and your pipeline is ready to run if everything goes well. So let's see the pipeline again with pipeline.show now. All right, so now we have the fetcher, it goes to converter, then we have the prompt builder, then it goes to the LLM. So everything is kind of similar to the image that I showed you initially. All right, let's run this pipeline. So I go say pipeline run. So there are things that I also need to pass to my components. For example, I haven't said anything about the URL yet, so I will be passing that URL to the fetcher so that it fetches the content of the web page. So what I'm going to do, how I'm going to do that is I have this data field, and again, I am using the fetcher name here, and I'm saying that as the URL, you should get the Haystack page. Paste it here. And another thing that I need to pass is the query to the prompt builder. So because usually, I mean, if this is a web QA system, there will be a query from the user. So I need something to pass that to my prompt builder in runtime. So I will do that. Prompt builder and a query. And this will be the query that I will be passing. I forgot a comma here. So what can it be? I can ask like which components are needed for a RAG application. This can be answered by checking the content of this website, but let's go. All right, yes, it says that missing input for component fetching URLs because we passed URL here instead of URLs. All right, yeah, another nice error, input query not found in component prompt builder. It's because we haven't said that it's query, we said that it's question. So let me go and fix that. So the variable names depends on us. All right, so we get an answer. To build a retrieval augmented generation application using Haystack, you need the following documents: retriever. Then I get some information about the prompt builder. Then there are like text embedders, the generators. So it makes sense. So this is how you can easily create a web QA application, and you can replace this URL with anything else. You can ask other questions, and in just like 5 minutes, you can ask anything to your web page. So this was my first example. In Haystack, there are a lot of components. If you check the documentation, you'll see a very huge list of components, but there is no way that we provide everything that you need. That's why we also provide this custom components options, which means that this is a pipeline image. And sometimes you have something specific for your company or very custom tool that only, I don't know, like very few people uses. If you want to incorporate that tool to your Haystack application, you can easily do that by creating your own custom component. And when you create a custom component, if you follow the architecture, you can easily incorporate that into your pipeline. And what you need for a custom component is quite easy. First, you come up with a class name in Python, and we have this component decorator that comes with Haystack. You just import it from Haystack. And the second thing that you need to do is to have a run method in that. You can definitely have an init method or other methods as well, but run method is mandatory. You create a run method with an input, or it may not have any input as well, depends. And then you do anything, then you return a dictionary. And this dictionary type, you also need to define with another decorator here. So you say like component.output types, and you need to give the name of your key and the type of your key here. So for example, here, I just get a name from as an input, and I generate a text using that name. And and this component returns this generated text in string form. So maybe let's quickly run this one. All right, so I can say that this is my component and initialize it without anything. And then I can come and say that maybe run it with Bilge. And what I will be getting is, hello, my name is Bilge. And then you can do whatever you want. You can connect this component to other components in your pipeline without any problems.
I think that's great. And if I would like to explore, for instance, how is the, I don't know, the LLM or the retriever object, um, can I explore? I mean, of course, I will not make you go there, but it's something that I can explore, because if I need to create, for instance, a new retriever because the function is different or something is different, can I go there and explore how you did it? Because
Yes, you can do it. And I really love that option. So you have this pipeline run, and in your run, in addition to data, we also have another field here. We have includes, I hope I am right here, includes outputs from right. So here you pass a list of components that you like to see the outputs. For example, in this pipeline, I use the fetcher, converter, prompt builder, and an LLM. I already see the output of an LLM, so it doesn't really make sense, but maybe I can try to see how I render the prompt. So I can type the prompt builder here and see what this prompt builder actually did. So the result that I get is a bit long, because now I have the prompt builder and the rendered prompt. And here I see, like, answer the questions based on the given documents. And I was providing some documents here. And remember, there was this Jinja syntax that I used. There was a for loop here, right after this document.
Yeah.
And here I see that it's filled with the web page content. And then where is that part? Yeah, this is all the prompt itself. Yeah, till this part. And here I have the question. And this is the question that I used to run my pipeline. So you can easily, check every component in a pipeline and see what they generated, what they outputted actually by taking this method.
That's great. That's great. Yeah.
All right.
For the audience, if you have any questions, just let us know and just put it on the chat. Sometimes if you see that I'm checking here, it's just because I'm checking the chat, and just to let you know. But yes. So let us know if you have any questions or anything that you would like to know. Just put it on the chat. Yeah.
Okay. I feel like I should be quite fast here, because now we know the basics of Haystack. I think we can easily go and create our agent. If I show you the pipeline, I think like everybody kind of knows how to connect the components to each other. So if you can imagine a pipeline, and I already have a pipeline image here, so just you can go ahead and already build your own pipeline. But I will also do it.
Quick question for the audience. What is an AI agent?
All right, so the AI agent is actually a system with a large language model. So the system can sometimes use tools, can have access to a memory, so the conversation history, and can also get the query from the user. And this agent, based on the prompt it uses, can define an action list to resolve a query. This is what I will be showing today. Nice. So the agents are kind of complex systems with LLMs, prompts, and sometimes tools and memory. So this agents can create action plans, can trigger some tools, get answers from tools, and combine them to create a meaningful answer to a user query.
Great, awesome.
But of course, how you form your agent kind of depends your use case, and sometimes by changing the tools of your agent, you can create completely different systems. And this is what I will be trying to show you with this use case.
Nice.
All right.
Great.
So since the Haystack pipelines are quite flexible and customizable, you can kind of build anything, and agent is also one of them. Here is one definition of Haystack with Haystack pipelines. So what I have in mind is I will have a prompt builder. This prompt builder will have a very sophisticated prompt and have information about the tools that I have, so my generator can have access to. And I will feed that information to my generator, which will be the agent of this whole system, you might say. This generator will get this prompt, and based on the user query, will define which tool to call and with which query to call it. Because sometimes you also need to change the query slightly to query a tool. Then this router component, based on the tool information, will direct the query to one of these branches that I have. And each branch is a tool here. And the tools that I have is a RAG pipeline based on some Haystack documents. This is my first tool. My other tool is web. So anything that you can search on search engines is my other tool. And my other tool is weather API. So this tool is kind of special. It's because it's custom. I've implemented it for this session, and the query to this tool is a bit different, so you might need to do some changes in the query. That's why we have our generator. So maybe let's dive in. So again, I am installing Haystack in this notebook as well. But don't worry, I will be sharing all of this with you, so you can also try to run this on your own. Okay, this time I will not be typing. I will just copy paste and explain the code to you just to be fast. All right. We need to have two API keys here. One of them is SerperDev. This is the search engine that we are going to use for our search web tool. And the other one is, again, Hugging Face API for generators. So let me go and grab my API key here. This is my first one, and for Hugging Face, this is the other one. So in this example, first I will show you this huge prompt that I have. Let me copy and paste it over. And then we can go over it together. All right. This is the prompt that I have. And what I do here is, if I go back here, let me also clear this. If I go back here, so I have three tools, but these three tools have different aims. So there are different reasons why I would be needing one of these tools. So this is what I'm explaining here. So I'm introducing the first tool, search web tool, and I add a description here saying that access to it when you need an information about recent events. I have another tool here, search Haystack, and this tool again will have a description like access to Haystack documentation. If you have any questions, like use this tool when you have questions about Haystack. And here I also define the query type and how it needs to formulate the query for me. And the last tool that I have for this use case is weather API. So this weather API will have access to the current weather based on the city name. So that's why in the description of the query, I say that this is the city name, such as like Paris, New York, etc. I have some instructions here. So I tell my LLM to select the most useful tool to resolve the user's query and respond in JSON format. But it's always nice to provide some examples in the prompt. So I'm doing that. So I'm passing some user queries, some imaginary queries. I'm coming up with a tool name, and then I showing how the query needs to be formulated. So what I expect from this prompt is when I pass it to my generator will need to detect which tool to use and with which query it needs to use it. So as you see, when user requests, why did Elon Musk recently see OpenAI, the query will stay the same. When I'm using search Haystack tool, the query will again be the same with the user request. But if I need to access the weather information, I need to change the query slightly. So instead of what are the weather like in Istanbul, I will be just getting Istanbul here so that I can trigger my weather API, get current weather information from it, and then get the relevant answer and get information. So again, I put my query variable here because this will be the user request coming from user, and based on this information, the LLM will decide on the tool name and the query. Oof.
Yeah, that was a lot.
And yeah, that's a huge prompt, but that's the thing with agents. There's going to be a huge prompt. Yep. And then here's what I'm going to do is I will put my prompt builder here. I'm passing this template and I'm just creating an LLM for agent with the same model that I used in my previous example. Mm-hmm. So that's it. So this will be my agent. Maybe we can be quite fast here and try this agent and how it performs so that we understand the rest of the example better. So I can directly pass this query to my LLM just to try something, and I will replace this query as if it was already replaced by the prompt builder and say like, what's the weather like in Istanbul? What I'm trying to do here is to replicate how my agent is going to behave. Let's run this. Yes, streaming is killing the network. All right. So we have a reply coming from the LLM, and it's in a JSON string. We are going to parse it later, but what we see here, we have the user request here. We have the tool name, so it chose the weather API, but it also changed the query with Istanbul. So this is what I'm trying to get. Let me replace it back to query and remove this line because I will be doing this. I will be doing everything in a pipeline. All right. So the next thing is creating the tools. So right now we are done till here, but we also need to create these tools. This is what I'm going to do now. So first, we're going to create our RAG, but maybe let's create the indexing for RAG first. So let me just take it here and paste it here.
We have a question that is, what is the name of the syntax?
Oh, it's Jinja syntax. INGJA. Jinja. All right, so in the meantime, I copy-pasted my indexing pipeline. Let me briefly go over it, and I will run it. So what I do here, again, I have some URLs. I will fetch content from these URLs. I will clean them, split them, and put them into my document store. I won't be creating any embeddings just to be fast here, but you can definitely create embeddings and then store them in your document store. And as a document store, I am using in-memory document store. This one is something that you can use in your demos. It's not for production, but it's quite handy if you want to just try something very quickly. So here's my pipeline. I have my components. I've already connected them to each other. Then now I'm going to run this pipeline, and this pipeline will get the content from website the content will go through all of these components, and it's now already indexed into my document store, and I get that there are like 14 documents written. And since I already have my document store and documents ready there, I can build my RAG pipeline here. So, and for this RAG pipeline, what I need is, as I said, for RAG, you need a retrieval and a generation. That's why I have an in-memory BM25 retriever here that is connected to my document store. This retrieval will get some query and retrieve relevant documents from my document store. I have another.
And your document store is locally. You are storing that in memory. Like you are not using any vector database or something like that.
No, I'm not, but you can definitely use it instead of like using in-memory document store. Here you can use OpenSearch document store or any document store that you have in mind. That definitely based on your use case, but it's not always handy to run them on Collab. That's why I prefer.
No, because you need to build everything on Collab. No, that makes sense.
Yeah. So for the RAG prompt, I also need another template for this one. This is quite similar to the one that I have for WebQA. What I do here is I give a brief information about the template. Then I feed in my documents here with Jinja syntax. I put my query here. You'll see some tags here, but these tags are necessary for the model. These, like if you are using any model, probably you are using different tags. I pass this RAG prompt template to my prompt builder, and I'm going to use another Mistral model, again through the serverless inference API for this RAG pipeline. So let me just create these components again. I am not connecting them to each other yet because this will be my last step. Now, one of my tools is ready. So let's go and do the web search part. So the web search part, the idea is quite similar to RAG, but the source of documents is different. Again, I can definitely use the same prompt that I have here, but I just extended it a bit to indicate that these documents were generated from search. So like say that out loud so that I know, but that's not a big issue. You can definitely use the same one. And the source of documents will this time be the Serper Dev web search component. This component will go to web, do like a search as if it's a search engine. It uses a search engine behind. And I've already given an API key in the beginning of this notebook. And it returns the content in Haystack document forms. So I don't need to do any conversion here. These are the components that I need. So web search components will go into this document section, and then LLM will just generate an answer for questions coming to this tool. So the rest of the pipeline is kind of the same. I have the generator, I have the prompt builder, quite similar to RAG. And something different that I have here is the weather API, because this is an external API that I will be using, and we don't have out of box support for this in Haystack. That's why I need to create my custom component.
Oh, nice.
So I have this. First, I need to provide my API key for this tool as well. It's free to use till some requests, but I don't recommend to use the free version of it if you are using it on production. All right, so let me also put my weather API component here, and let's go over it together. All right. It's again very similar to how I built the other custom component. I have my component decorator here. I have my class as get current weather, and in the init method, I just put the API key here. So this is what I will be expecting to pass when I initialize this component. And in this run function, what I do is I expect a city name in string format, and I return a text. And how I do it here is just I send a request to this API with the city name, with the key that I have, and it returns the request. It returns a result to me. You can go a bit sophisticated here, and you can like put it in a try, so that you catch the errors here. But just to keep it simple, we're not going to use it in production yet. So you can just use this request library to get a response. And from the response, I will just parse the condition. So is it going to be like sunny, partly cloudy, snowy, whatever? I will get the condition and the current temperature, which will be in Celsius. Then I will do a quick trick here, and I will create my own string instead of like passing it to an LLM and waiting for LLM to generate an answer for me. Because if you're trying to get the weather information, that's like you don't need to like create a long answers to that one. So this is my custom component that I will be using. All right, so if we go back here, we have this tool, we have the tool in the middle, and we have the weather API ready. We already had this ready here. Now we need to create our router, define our conditions, and then we are ready to go. All right. So the router that I will be using is the conditional router, and this conditional router is capable of getting some input, and by looking at the input and some conditions that I define, it can direct the query to different branches, and which is what I will be using today. I have my main routes here. Oh, no, here. So what I do here is, if the answer coming from the LLM has weather API in the tool name, pass that query to my weather API. And if I have a tool name as search Haystack, this is the condition, and you can again use the Jinja syntax here. Output query to my search Haystack branch. And if I have tool name as search web, maybe use search web branch for the query. So if you scroll again a bit back, here you see the branch names. This one is search Haystack, search web, weather API, and these are the tool names that I defined in my prompt. How I instructed my LLM to create a tool name. And if you see the output again, as the tool name, we have weather API, for example, for this one, and then we also have a query as a stump. Okay, so this router will get the routes and brought the response coming from the LLM to the correct branch. Let me run this one. But there is something slightly missing, because we need to do something slightly different. We need to parse the output coming from the LLM so that we can detect the tool name or the query differently. That's why I've also written another component, which is what I will be calling as the answer parser. And what this answer parser does is, if you remember, the response coming from the LLM is a JSON string. I need to convert that into a dictionary so that I can parse the answers. So I can parse the tool name and the query differently so that I detect the tool name, and then the conditional router uses that tool name to direct the query to the right branch. And this one only has a run method, and I just parse the reply coming from the LLM into tool name and the query here. All right. So I have all the components ready. I just need to create my pipeline and connect them to each other. So let me maybe put my pipeline here. So what I do here is I add components one by one to my pipeline. I have the names for them. I hope I have them correct, but my agent will scream if I get them wrong. So yes, I forgot something here. If I go back, yes, this one. All right. Oh yeah, I need to recreate the components, because I tried to run the thing again. Let me do that quickly. Another error. Oh, yeah. I need to go up, run these cells.
I think it's the name, right? Okay.
No, it's not the name. It's just trying. So when you're trying to add components to your pipeline, and once you add it, you cannot add it again, but it thinks that I'm adding the component again to my pipeline, but it's not the case.
Okay.
Actually. So, all right. Now we have our components added to our agent, but the connections are not there yet. So I will be doing the connections now. I will go step by step here. So the first connections that I will be doing is for the agent part of it. So I have this prompt builder for agents to do. So this massive prompt, I will pass that to my LLM. Then the LLM will connect to my answer parser so that this custom component that I have can parse the query and the tool name separately. Then I will pass both of these information to my tool router. Then by taking at the query and by taking at the tool name, the tool router can direct the query to the correct tool. Now I will be creating the connections for my tools. So the first tool that I have is web search. What I do here is I get the query from tool router's search web. I put that to my web search so that it goes out and checks the relevant information from web. And then I have this query. Here I have the query. I put that in my prompt builder as the query. Then I get some documents from web search. I connect these documents to my prompt builder for web search, and then my prompt builder to my LLM. So this is the first branch that I have for this tool, for this agent. Then I have RAG. RAG is quite simple. Again, the idea is the same. I have one branch, search Haystack branch. This is the source of my query. I'm connecting to my retriever to retrieve relevant information from my document stores. Then I have my query here, again, for my prompt builder. I get relevant information from retriever. I put that into my prompt builder, and my prompt builder will render the prompt and pass it to the LLM. And as the last part, it's the easiest part because it's only one component as a tool. I just have this tool router weather API branch providing the query, and I give that information to my get weather component in my pipeline. So I'm running this one. Seems all right. Let's maybe do agent.show here and see how our pipeline looks like. All right, so this is a very huge pipeline. It can look complex because it's kind of complex. Like it starts with the agent, so-called prompt builder, and the LLM. Then I have the answer parser, tool router. It goes to other components, but you can see every connection here. So let's run this agent with a query. So how I'm going to run this thing is I just provide a query, anything, to my prompt builder for agent, because that's the first component that I have here. I just provide it there. And as a query, I can provide anything. So I can maybe say like, what's the weather like in Toronto? And if you want, you can use this include outputs from and see the outputs of specific components. But maybe as the first step, we don't need it. All right, let's run it. What do we get? All right, it tells me that the weather in Toronto is partly cloudy with 19.2 degrees. Is that correct?
Yes, it is. Yes, it's weird for the summer, but it is what it is. Yes, it's correct.
So yeah, maybe we can try other queries here. So we are using the same pipeline, but this time we are changing the query. So we're going to force it to use other tools here. So I'll go and ask like, can you tell me why cats purr? So it should definitely go to web and try to find an answer to that question from web. And to see that, to see the source of the output, maybe I can add this one here and try to get the response maybe coming from the LLM. Yeah, I can try to see what this LLM generates. So LLM for agents.
Yeah.
Or agent. Let's run it. So the reply coming from the agent is, again, user request, this query, and it uses the web search, but just shorten the query as why do cats purr? And this is the answer that I get. Cats purr for a variety of reasons, and it's not always an indication that they are not feeling good or happy, etc., etc. And I know that it's generated from web because this is the component, like LLM from web component. So this is the agent that we have implemented. And by introducing new tools to your prompt and to your pipeline as well, you can create very custom AI agent here. As do we have time for the UI part of it, I will just connect it to a UI. But if you don't have time, okay.
Yeah.
Okay, so again, I will stay in Google Colab. I will do something a bit fancier, but I see that I am a bit dark, so I'm going to turn on my light here.
It's late for you. Yeah.
Yeah, now it started to get late. So Gradio is a great application. It provides some ready components that you can use to build your own UI. And if you have this chat interaction, it already has some components ready. So I don't even implement anything sophisticated here. So I just imported that. Maybe I hide that. And let me go back and put my code here. So I'm doing copy pasting a lot, but I'm explaining everything. So this is actually the code that I need for Gradio. I just imported as gr, and when I call the chat interface of it, what I need to pass is a function that it's going to call when there's a user input. Some examples just to make things easier, definitely not necessary, and title to make sure that it's explanatory for people. And for the function here, what I do is I put the same pipeline, but as the query, I get the message coming from the UI I pass it to my pipeline, and the rest is just the same. I get a response, and I check the response step like one by one. You can go more clever here and maybe detect the tool, because we have access to everything happening in the pipeline. So if I say like, if there's LLM for web in the answer, get done. If there's LLM for RAG, returning the answer, get that. So if the web search, RAG, or the weather API that we have, it gets the answer and returns that answer. So let's run the cell. And the last step that I need to do is to demo the launch here. And we're going to have our UI ready. Oops. Loading. Yeah, we have it. So this time I can go and ask, what is Einstein's first name? It goes, so first it tries to detect like which tool it needs to use, then it queries that tool, gets an answer. So it says that based on the provided documents, the first name of Albert Einstein is Albert. Well, that's a nice information, thank you. So it says that it also gives some information about where it found this answer. And I can then ask, what is Haystack? And submit it. And now it goes through the process again. So Haystack is an open source framework for building production-ready LLM application, etc., etc. So it has access to 3 tools at this point. It can use all of them based on the user query. Feel free to extend it as you like. Are there any questions? Maybe I can start answering questions.
I do have 2 questions. I mean,
Yeah.
The first one is it's not a question, but is if you go up when you are explaining, when you show all the if you go up more yeah, to the top, more when you show the architecture at the beginning,
Yes.
like that part, you are actually using, and that's very interesting, and that's why I think that's very useful even for any developer that would like to use it by his own. I mean, if they would like to create something, because you are actually using the generator in the middle is the one that is, you're using an LLM to create a JSON file and to detect which kind of question is it, right? Because that's something that is challenging sometimes when you would like to direct or to detect what is the topic of the answer of the question of the user, right? So when you're using that LLM, is there any restriction or something that you said? I mean, I've seen that it works well with Mistral, with Llama, with OpenAI, whatever. Do you have to pay attention on that kind of LLM? I mean, is that something that I need to pay attention when we are deciding that kind of LLM?
Yeah, so if you are using like small LLMs, I know like there are large models, but some of them are relatively small and not all of them are capable of like generating this JSON format. And for example, if you just remove this example part from this prompt and try to get the same result from this Mistral 7B instruct model, you might also fail. So you kind of need to do a bit of prompt engineering based on the prompt. And here, as you see, I've also have some tags here. So what I've seen is not every model is capable of doing that. So you need to go with the bigger and newer models. Okay. So this Mistral model is quite relatively new one. So this one supports, but I haven't tried, but probably the first version of this model will struggle if you have, I don't know, more than 2 tools, or maybe it will struggle with generating the JSON format. And something that is very important here is, it's nice that you mentioned it. Can I run this part again? I'll go ahead and do that. So if I do this, or maybe let me not do that, it will take some time, but the response coming from the LLM should not require any additional text. It should only include the JSON string. Otherwise, we cannot parse it correctly. Yeah. So you might need to also include some instructions to your LLM, as I did. So respond in JSON format. Don't put anything else. Sometimes it puts this 3 backticks with JSON in it, saying that it's a JSON, but I don't need that. I just need this string. Yeah. So you can try and see, but yeah, these are the things that you need to pay attention.
No, that's great. Yeah, no, that's great. I have one more question, and if any of the audience they have any questions, please let us know. One is you created these custom components, right, for the weather agent. If
Yeah.
I'm a developer, like, and if I would like to know if there is any custom, I mean, is there any repository or something on the GitHub or whatever where people can contribute their own custom agents or blocks? Because I think
Yes.
that would be useful to not just to not reinvent the wheel, right? Because I think that's one of the main goals on our Haystack, which is great. I actually love it. Is try to avoid the reinventing, right?
Yeah, exactly. Nice that you brought that up. So let me share the Haystack website here. So we have this integrations page, and here you will see the integrations that we have already.
Okay.
Some of them are maintained by us, some of them are contributions from our community. There's, for example, where is that? So there's Mastodon Fetcher, for example. It gets some data from Mastodon, and then you can use information retrieved from Mastodon. This is implemented by a community member. And we have Notion Extractor, or integrations with other tools as well are here. So first check this website, and then if you don't see any use case here, implement your own component, let us know, and we'll create a page for you. And you can also create a page for your integration there.
Awesome.
So this is the first place that you need to look. But of course, check Haystack core repository first.
Nice.
Because we have a long list of components. Maybe there's already support for it there. Yeah. And if there's not, you cannot. Then you can check the Haystack integrations.
Nice. I mean, I think that it's a great tool. I think it's very useful for if you are in that stage when we are developing that. I think that it's a great tool. I know that we are a bit running out of time. But I would like to let you know. Well, any questions? Again, just let us know. It's anything else like closing remarks, closing comments that you would like to? I mean, which are your networks and something that people would like to know in order to contact you or Haystack?
Yeah, so I am available on LinkedIn and Twitter, so you can find me there. And if you'd like to learn more about Haystack, we have a Discord channel. So you can definitely, if you go to haystack.deepset.ai, you'll definitely see the link to our Discord server. Join us there. We host some office hours, and you can also share what you've built with Haystack there with us and with other people in the community. Yep. We are also sharing the updates there when there's a new release. We try to help you with questions, so I'm inviting everybody to join us there.
Nice, great. Yes, I mean, it's a community-oriented project, so people can contribute, people can be part, so don't hesitate to contribute. Yes, I think, thank you for everything. I mean, I love the use case, I love the session, I really enjoyed that, so thank you so much, Bilge, for being part of this. We really appreciate you having here, so thank you so much. And for the audience, I mean, stay tuned. We'll be doing another session probably next month, so stay tuned. Thank you so much for everything. Thanks, Bilge, and see you next time.
Thank you.
Thank you.
See you, everybody.